Hello, my name is Oscar, and today I'm gonna work on chapter 3 and 4 examination, but I'm gonna work specifically in exercise 4.1. So to start with examination, we're gonna go through the part A, and the problem says, three professional wrestlers are fighting over a champion's belt, and each exerts a force on the belt. Wrestle 1 exerts a force F1 equal to 40.0 newtons in the x direction. Wrestle 2 exerts a force F2 equal to 80.0 newton in the y direction, and wrestle 3 exerts a force F3 equal to 60.0 newtons at an angle of 36.9 degrees, counterclockwise from the x direction. Find the x and y components of the net external force on the belt. So we know the wrestle number 1 applies a force of 40.0 newtons. We can say this is in the x axis. Now, wrestle 2 applies a force of 80 newtons, 80.0 newtons in the y direction, or we can say y axis. Now, wrestle 3 applies a force of 16 newton, but the force that this wrestle applies has an angle that is equal to 36.9 degrees about the x-axis. So we can say this one right here is gonna be wrestle number 2 with a force of 80 newtons. Let's say 80.0 newtons. This is going to be wrestle number 3 with a force of 16 newtons. And here is the angle of 36.9 degrees. And here we have wrestle number 1 with a force of 40.0 newtons. So we need to find the let me see. So first we need to find the x and y components of the net external force. So to start with this, we need to find the force that the wrestle 3 is applying in the x-axis and y-axis. So for this, we have the F3x and F3y. And this is gonna be equal to the force applied, and like x is the horizontal angle, we have to use cosine of the angle, and for y, like is the y axis, we need to use sine. So force by times sine of the angle. And this is going to be F3x equal to, we have 16 newton cosine of 36.9 degrees. And for F3y, we have 16 newton times sine of 36.9 degrees. So F3x is gonna be equal to 48.0 Newton, and F3y is gonna be equal to 36.0 Newton. Now that we know that F3x is equal to 48.0 and F3y 36.0, we can find the F net of each component. So for x, we're gonna have Fx is equal to Fx of result 1 plus Fx of result 2 plus Fx of result 3. This is gonna be equal to 40 Newton plus, we know that result 2 is only applying a force in y-axis. So like it's not applying a force in the x-axis. This is gonna be equal to 0 plus Fx of result 3, that it's going to be equal to 48.0. And this is gonna be equal to 80.0 Newton. So Fx is equal to 48.0 Newton. Now we're gonna do the same. Okay, sorry. I just realized I had a problem in my math when I was reading the problem, and my y force is negative because it is applying a force downward the y-axis. So instead of going up and being positive, this force is going down. So result 2 is equal to minus 80 Newton. So this is wrong. And here result 2 will be negative. So it will be Fy equal to Fy of result number 1 plus Fy of result number 2 plus Fy of result number 3. It will be equal to 0 because result number 1 is only applying a force on the x-axis, plus minus 80.0 Newton plus 36.0 Newton. This will be equal to minus 44 Newton. So the answer for part A answer is Fx, Fy equal to 88.0 Newton, minus 44.0 Newton. So now we're gonna work on part B. This part B, is the next part of part A. So for part B, we have find the magnitude and direction of the net external force on the belt. So for this, we already know that Fx is equal to 88.0 newtons, and Fy is equal to minus 44.0 Newton. To find the magnitude of the net force, we're gonna use the next formula. So, force is gonna be equal to the square root of Fx exponent of 2 plus Fy exponent 2. and this is going to be equal to F equal to 88.0 exponent 2 plus minus 44.0 exponent 2, and we're gonna do the square root. The result of this operation is gonna be F equal to 98.4 Newton. So here's the magnitude. Now we need to find the angle or the direction. So the angle is going to be equal to the arc tangent of absolute Fy over Fx. And this will be equal to arctangent of minus 44.0 over 88.0, and this will be equal to 26.6 degrees. We know that Fy is negative, because if you remember, we have the graph going like this. This was result 3, this was result 1, and this was result number 2. Like result number 2 is going down, this will be negative. Result number 1 is going to the right, this will be positive. And we know, like, since Fy is negative, the vector is below the y-axis. So it will be the angle equal to 26.6 degrees. So the final result will be 98.4 newtons. This will be the magnitude of the force, and the angle or the direction will be 26.6 degrees. Clockwise from the positive angle. I mean x. Positive from the positive x axis. Okay, so now we're gonna start working on part C, which is different from part A and part B, which are the same exercise, but just different parts. So part C, or let's say problem 2, says 3 forces act on a statue. Force 1 has a magnitude of 45 Newton, points in the positive x direction. Force number 2, with a magnitude of 105 Newton, points in the positive y direction. And force number 3, with a magnitude of 235 Newton, is at an angle of 36.9 degrees from the y direction, from the negative x direction, and 53.1 degrees from the positive y direction. Counterclockwise from the x direction, find the x and y components of the net external force on the statue. So we know F1 is equal to 45 Newton, and this force is being applied, let's do the right, because it's on the positive x-axis or x direction. F2 is equal to 105 newtons going up because the force is being applied on the positive y-axis. And F3 is equal to 135 newtons with an angle. The first angle is gonna be equal to 36.9 on the negative axis of x, and we have the second angle which is equal to 53.1 on the positive y-axis. So that means that we know the x is negative and y is positive. This is on the quadrant number 2. So if we make a small graph, it will look something like this. This will be force number 1 equal to 45. This will be force number 2 equal to 105. And this right here will be 235 Newton equal to force 3. So now we have to break down force number 3 to find the x component and y component. Since the angle is relative to the negative x-axis, we're gonna have F3x equal to minus force 3, because it's being applied to the negative x-axis, times cosine of the angle. This is going to be 235 cosine of 36.9, which is equal to negative 188 Newton. Now for Fy, F3y, this will be the force. This one is positive because the force is being applied in the positive axis of y, times sine of the angle. So this will be equal to 235 sine of 53. Sorry. This will be 235 sine, but we are not using the 53.1 angle, we're using the angle 36.9 because the angle is relative to the negative x-axis. So we're gonna use 36.9. So 36.9. And this will be equal to 141 Newton. So now we have F1 equal to 45, let's do x, y. Comma 0. F2 is equal to 0, comma 105. And F3 is equal to negative 88, comma 141. This is the x-axis and this is the y-axis. So now to find the fx component, fx is gonna be equal to the f1x plus f12x plus f3 x, and this is gonna be equal to 45 plus 0 plus negative, which equals, all of this is equal to negative 143 newtons. Now we're gonna do the same for Fy, which is equal to 0 plus 105 plus 141, and this is equal to 246 newtons. So Fx comma Fy is equal to negative 143 newton, comma 246 newtons. This is x, this is y, and this is the part C answer. For part D is a continuation of part C, or let's say problem number 2. And the part D says, find the magnitude and direction of the net external force exerted on the statue. So to find the magnitude, we know that the formula for magnitude is gonna be F equal to the square root of Fx exponent of 2 plus Fy exponent of 2. We know the Fx is equal to negative 43 newtons, 143 newtons, and Fy is equal to 246 newtons. So F is equal to negative 143 exponent of 2 plus 246 exponent of 2. We add the square root, and F, or the magnitude, it's going to be equal to 288 newtons. So this is the first part of part D. Now we need to find the angle or the direction. So to find the angle, we know that arctangent times Fy over Fx. This is the formula to find the angle. And when we plot the numbers, we're gonna have arctangent 246 newtons over negative 143 newtons. This will be equal to negative 6.1. So now, this is the angle but we know that the vector, or the force the force number 3, it's being applied on quadrant number 2. So we know the angle is gonna be equal to 180 plus the angle. So now that we know that the angle is equal to 60.1, we just need to find the right angle, because we know that our angle is on quadrant number 2, because x was negative and y was positive, which means is quadrant number 2. So the formula to find the angle or on quadrant number 2, will be quadrant number 2 is equal to 140 minus the reference angle. So quadrant number 2 is equal to 180 minus 60.1. So quadrant number 2 is equal we're gonna round, so this will be 120 degrees. So the magnitude of the force is equal to 145 newtons, and the angle or the direction will be on quadrant number 2 equal to 120 degrees. This will be the answer for part D. So now we're gonna start working on part E, which is a different exercise. Let's say or name it like problem number 3. And we're going to do basically the same stuff as the other last two exercises. So our force number 1 for this one, this is the example is about an eagle descending. So force number 1 is equal to 60.0 Newton, and like it's going down, it is negative on the y-axis. Second force is going to be equal to 60 newtons with an angle of 20 degrees. On force number 3 is equal to 50 newtons with an angle of 20 degrees from the x-axis, from the negative x-axis, and an angle of 70 degrees from the positive y-axis. So, having these three forces, we know that F1, okay, let's do it like this. So we have X, Y, F1, F2, and F3. So F1 is going to be 0 in axis X, in the X-axis, and it's gonna be negative 60 on the Y-axis because it's going down. To find the X component and the Y component of F2, we're gonna use the formula that is Fx is equal to the force which is negative because this one is going from the so now we need to find the X and Y components of F2. So we know the formulas. F1, Fx is equal to the force sine of the angle, and Fy is equal to the force cosine of the angle. So Fx is going to be equal, the force on this one is going to be negative. Why? Because it's on the left side of the vertical axis. So it will be minus 16 newtons times the sine of 20 degrees. And this is going to be equal to minus 20.5 newtons. For Fy, we have the force, which is positive. This is going to be 60 cosine of 20. So Fy, Fx, is equal to 56.4 newtons. This is 2. So we know minus 20.5 and 56.4. For F3, we're gonna do the same thing. For the force number 3, we need to find the x component and the y component. So we're gonna use the formula. X3 is equal to force times cosine of the angle. And right here we're gonna have Fy3 equal to force sine of the angle. And the reason we're using right here in Fx3, we're using cosine for the x component, but for F2 we're using sine. The reason is when we're using sine on force number 2 because we're using the vertical. We're going through the vertical axis, but right here we're using the horizontal direction. So now we just need to find the x and y component for force number 3. But if you take a look, when we find the x component for force number 2, we were using sine instead of cosine, and this is because we're using this using the vertical direction, so it changed. So when we are using the vertical direction for x, instead of using cosine, we use sine. Right here on force number 3, we are using the horizontal direction, so that's why we are using the cosine for the x component and sine for the y component. So if we're going vertical, x is going to be equal to the sine, and y it's going to be equal to cosine. And if we're going horizontal, x is going to be equal to cosine, and y it's going to be equal to sine. So the force for the force number 3, it's going to be equal to 15, but this is going to be negative because it's being applied on the negative side of the x-axis, times cosine of the angle, and we're gonna be using the angle 20. So this is going to be equal to minus 14.1 Newton. And Fy3, it's going to be 15. This is positive because it's being applied in the positive side of the y-axis, times sine cosine of 20 degrees. Once again, because it's relative to the x-axis. And this is going to be equal to 5.1 Newton. So minus 14.1, 5.1. Now we just need to add all the forces to find the x component and the y component. So fx is equal to f1x plus f12x plus f13x, and fy is equal to f1x plus f2y, y, plus f3y. Fx is equal to 0 plus minus 20.5 plus minus 14.1. So fx is equal to 6.4 Newton. Fy is equal to minus 60 plus 56.4 plus 5.1. So Fy is equal to 1.5. So Fx, Fy is equal to 6.4 newtons, 1.5 Newton. Right here. So f1x plus f12x plus f13x, we have the values right here, which are the same values right here. We add all of them, and this is going to be equal to 6.4 Newton, which is the fx component. And we do the same thing for fy. We add all these three values, and the result is going to be fy equal to 1.5 newtons. And this is the answer for part number E. Now, part F. This is the continuation of part E, or problem number 3. We just need to find the magnitude of the force and the angle or direction. So, once again, F is equal, or magnitude of force is equal to the square root of Fx to the 2 plus Fy to the 2. We know that Fx is equal to 6.4 newtons and Fy is equal to 1.5 newtons. So F is equal to the square root of 6.4 exponent of 2 plus 1.5 exponent of 2, and F it's gonna be equal to 6.16 newtons. Now to find the angle is equal to the arctangent of Fy over Fx absolute. This is going to be equal to arctangent 1.5 6.4. This is equal to 13 degrees. So the final answer is going to be the force equal to 6.16 newtons, and the angle or direction is going to be equal to 13 degrees from the positive x axis. So now we're gonna start with the part G, which is the problem number 4, the last problem of the exercise number 4. For this exercise, we know 3 people Ernesto, Kamala, and Sudoku. All of them are pulling the one pizza. The first force, which is being pulled by Ernesto. So Ernesto force is equal to 35.0 newtons. And he's applying the force to the east. So we know the north, south, east, west. So east, it means positive x. We have Kamala pulling with a force of 15 newtons. She's pulling to the north, so this will be positive y. And we have Sudoku and she's pulling, but we don't know the force that she's applying. She's applying the force to herself with an angle of 30 degrees to the north, to the south of west. South of west. And when she applies the force, we know that the net force is equal to 24 newtons. So F net force is equal to 24 newton. If we do the graph, we're gonna have something like Kamala, we're gonna have Ernesto. We know that this is the south is going down, so go down, and the west is to the left, so the angle is gonna be like right here. So the force it's been applied by Tsudoku, it's right here with an angle of 30 degrees. So now we know that F net x is equal to the force times cosine of the angle, and F net y is equal to force sine of the angle. So F net x is equal to minus 24.0 cosine of 30 degrees. And here we're gonna have the same thing, but instead of using cosine, we're using sine. So F net x is equal to negative 20.8 newtons, and F net y is equal to negative 12.0. So F net is equal to 20.8 newtons in the x component, and we have negative 12 in the y component. So now we know that every time we find the F net, we do the sum of three forces together. So F net is equal to force number 1 plus force number 2 plus force number 3. like we need to find the force number 3, which is the force that Sudoku it's applying to the sud of the west. So this will be equal to minus 20, comma, 12.0, because this is the Fnet. We already find Fnet, so we just need to replace the formula so we can find force number 3. F1 is equal to 35.0, comma, 0 plus F2, which is equal to 0, comma, 50.0 plus F3. So we don't know the values of F3. So we just need to replace the formula so we can find, sorry. This is the formula. We just need to replace the values. We need to plot all the numbers. We know Fnet, we know F1, we know F2, but we don't know F3. If we replace the formula to find F3, this will be equal. So let's divide. Fx is equal to Fnet minus F1 so this will be equal to Fnet x. This is adding, so if it goes to the other side, now is subtracting, so minus F1x, same for F2, minus F2x is equal to F3. And we're gonna have the same formula but with the y component, so that means that Fnet y minus F1x minus F2y is equal to the F3y. So it means that we have F3 equals to minus 20.8 minus 35.0 minus 0 F3 x is equal to negative 55.8 newtons, and Fy3 is equal to minus 12 minus 50 minus 0. Fy3 is equal to minus 62.0 Newton. So it means that the force the Sudoku it's applying on the pizza, its x component and y component is equal to negative 55.8 Newton, comma, negative 62.0 Newton. And this is the answer for part G. Part H. And for part H, we need to find the magnitude and the angle or direction. So this is going to be, to find the magnitude, we have the force is equal to the square root of fx exponent of 2 plus fy exponent of 2. We know the f3x because we're finding the magnitude of the force applying by Sudoku. So f3x is equal to minus 55.8 and f3y is equal to negative 62 newtons. So F is equal to negative 55.8 exponent of 2 plus negative 62.0 and the square root. So this F is going to be equal to 83.4 Newton. So that's the first answer. Now we just need to find the angle. We already know that to find the angle or the direction, the angle is equal to the arctangent of the absolute of dy over of dy of fy. Sorry, of fx. So this is equal to the arctangent absolute of negative 62.0 over negative 55.8. And this is going to be equal to 48 degrees.